All right, guys, anybody have any questions from homework stuff or from the quiz? Or remember, this week there's a quiz on Wednesday on proportion hypothesis tests. So you guys doing all right out there relatively? Okay. Okay. If there's no questions, we're going to jump into the next chapter, guys. Actually, the next chapter. Number 1 from the quiz. Let me see. Hold on. Oh, crap. Where's everything? There it is. Monday, Wednesday quiz. All right. So number 1, the one about Alaska, right? Let's see. What part did you have trouble with, Mineski? A. Oh. All right. So I'm not going to do too much of this because you can do this for corrections, but you always look for words like believe, think, feel. Obviously, claim would mean that's the claim. So in this one, the second sentence says, we feel that the mean is the same now. So then the claim is mu equals 18.1. And of course, since it has an equal sign, it's going to go in for the null hypothesis, right? I mean, that's, so you end up with a two-tailed test on that one. Is that all right? I mean, that's really all part.
Yes, but part D, right?
D, okay.
So it doesn't always mean if it's equal to fail it. Like reject, fail to reject and fail to support, because based on the last example we did with the equal sign, we ended up failing both.
Okay. So the equal sign only tells you how many tailed test it might be. It has nothing to do with if the claim is going to work or not. I mean, that only depends on if you get into the rejection region. That's the only thing that matters as far as if you reject the null or not. Does that make sense?
Okay, yeah.
And then, of course, the claim itself, in this case, is the null. So a lot of people had trouble still with the conclusion. The null is the claim, so I use the language that goes with the null, which is reject. Right, so either I'm going to reject the claim or I'm going to fail to reject the claim.
Okay.
I like it.
That clears it up. Thank you.
Sure. Anybody else? Questions from homework or the quiz or general questions? Okay. All right. Okay, kids. So we're going to get back. If there's no questions, we're going to get back. We're going to do the next chapter then. Like I said earlier, the next chapter. So we actually go to chapter 12 because I like to give you a break from, so we've got 2 charts so far, right? We've got Z-score chart and T-score chart. Chapter 11 gives us another chart. So I figured I'm going to jump to 12. I like to do this, give you a break from all the freaking charts, right? So we don't have to learn a new chart all of it quite yet. So we're going to get into chapter 12. So I'm going to put it up here on the screen. Oh, I've put this worksheet I'm about to show you. It's up in the pages on Canvas. So you can get in there and take a look at this later. So I'm going to, did you have somebody have a question? I saw, everybody all right out there? Okay, I'm going to share the screen. Okay. You guys see this problem about beer? Is it beer, Jeff? I just said drinking, so it could be anything.
Yes.
Yes, thank you. All right. So, all right, here we go. So you might have heard something about how things are correlated. Two things are correlated. Did somebody have a question? Is everybody all right? Okay. So what we're about to get into is what's the relationship between two variables? And if there is a relationship between two variables, it does not mean that one causes the other, right? In fact, even if one did cause the other, I don't know which direction it goes. I don't know which one causes which. That's not what this test can do. So for a really, really, really dumb example of this, say that I went and observed multiple basketball games. And I decided, I see a correlation, and I write down, oh, playing basketball makes you taller. That's obviously crazy, right? Because I play basketball, and I'm not very tall, which is why I didn't play it on a team too often. But I got a good fadeaway. So that's an incorrect interpretation about which way the causation goes. So even if I see two variables are related somehow, that doesn't mean I can tease out which one causes the other one. I'd have to do a much more complicated analysis. All what we're about to do is show that there is a relationship between two things. There could be a third thing causing that to happen or whatever. Okay, maybe. All right, so for example, look here. I don't know if anybody's been reading this. This is, by the way, my obligatory statement. This is not in any way a request to do this experiment. Okay, Dean? Okay. But I love this example. Say that you went out drinking, a whole class. Everybody's like, man, I can't take a Waller. Shit, 7:30 stats. And you go out drinking the night before. Actually, you can't go out. So you have a Zoom drinking session with each other, right? With whatever you have on hand. And you're drinking away into the night. And then you have to get up early, obviously, and take your test, take the final. And I want to plot what the grades in the grades on the test and the number of beers. Let me just plot them. So for example, this point right here, any of these points, but this point right here, that means that person, what does that mean about that person? Did they drink a lot or not much? That person right there. Can you guys read that? Well, let's try again. Which axis is the number of beers they drank? Yeah, they drank a lot. I mean, this axis is the number of beers. So relative, now, Sircon, I don't know how much you normally drink, but I didn't put a scale on there. But relative to everybody, this person drank tied with the highest number of beers. You guys with me? So relative to the class, they definitely drank, these guys drank a lot. But somehow, how did they end up doing on the test? Got a high grade. Okay, so some people can deal with their liquor better than others. And obviously, this person probably knew their stats pretty well, right? So let me erase that, go away. What about this person down here? Did they drink a lot? No, they relatively drank like the second least. But did they do well on the test? No, relatively they did bad, right? Now again, I didn't put any scale in there just because I don't care. But is there still a trend overall? Those are the two outliers, that one and that one. They are outliers for this data because they don't follow the trend that the other data points set up. Is the trend a downward trend or an upward trend? As the number of beers increases, yeah, the grade seems to go down. So this would be a downward trend. So I can draw sort of that line I just drew. It's probably not perfect, but can somebody tell me what that line I drew is trying to do? Let me try to draw it again. I can't help it. Let me make this a little less. This line I'm drawing, can anybody tell me what that line is trying to do? It's supposed to be a straight line. That's good enough, Jeff. Just let it be. Let it be. Let it be. Anybody? Anybody? We could do it. We could do it. Okay, okay, that's okay. There seems to be some kind of possible correlation. Let me ask you this. Is it a strong correlation? Especially compared to this guy. Look at this other one. Look at this one. In fact, you can't say that, Olivia. You cannot say that. But we'll come back to this. Is this one stronger than the first one? Which one's got is a stronger correlation? Which one of those two is stronger? The first one or the second one? Which one's stronger? Definitely the second one, right? So you inherently understand what a strong correlation means. What does a strong correlation mean? Why is the second one stronger? You could do it. Excuse me. All right. What about the data points themselves compared to the line? Yeah, there's no outliers, but you can still have a relatively strong correlation with some outliers. More data points do what? What do the data points do? I don't think there's more data points. They're just not as, the second one's data points. Yeah, the second one follows the trend, but so does the first one. Not as scattered, definitely. I love it. So the data points in the second one are tight to the line. They don't vary from the line as much. So stay with me, stay with me, stay with me, stay with me. The line is a graphical average. Let me say that again. That line I'm trying to draw is trying to be the graphical average of all the data points. Do you guys agree with that statement to some degree? You're like, well, you're the dude that knows stats with the shit, but I mean, I want you to agree with it, really. Yes, no, maybe so. Do you guys see what I mean by that? That line I'm drawing is the average. And then so what's the other thing that's important to know is how far away do the data points get from the average? So if I say which one is the stronger correlation, it's the one that's got less variability. The data points get away from the line less. So a lot of this stuff we kind of inherently understand. We know what it is. We just have to get used to some of the terminology. So this one is obviously the stronger relationship. Oh, let me beef up my bam. This one is definitely the stronger relationship. Which one's more realistic? Which one would be closer to real life? The first one or the second one? Nope. What's going to happen in real life? You're going to have people that no matter how little they drink, they're going to do poorly, right? It shouldn't just depend on the number of beers. There are other variables that affect your grade. If it just depended on how many beers you drank, then you would just not drink anything the night before test and make an A every time. Wow! So the first one is more realistic because there will always be some data points that buck the trend. All right, I like it, I like it. But the second one definitely shows a stronger correlation. So what about this one? Hours studied is another variable that I think I've heard that it affects your grade on things, is how long you study. Which one of these two is stronger correlation, the first or the second? Definitely the first one, right? Oh, crappity doodah. Well, actually, let's get out of there. Just go away. You could do it, Jeff. You could do it. You could do it. You could do it. No, you can't. You can't do it at all. Pretend like that's a straight line. Oh, that's so bad. I have to let go of it. Okay. And this one still has an upward trend, right? It still has an upward trend, but again, the data points get further away from that average, that line in the middle. And then my outliers, here's an outlier right there. What is true about that person right there? That is a person. I have smushed them into a dot and put them up on my screen. That's what I do at the end of every semester. So hopefully you got your affairs in order. What is true about that person? Did they study much? That person right there didn't study much. They did well without studying. And what factors might have affected that? Maybe they took the course before and just sucked on the final and barely failed, so they take it again, right? Or maybe they just get it. They just get it. They didn't have to crack the book. And then, of course, the other outlier, this poor person over there, that poor person right there did pretty bad, right? But they studied supposedly a lot. I would argue they probably don't know what studying is, maybe. Or they just have a lot of trouble with this, or you never know. You guys with me? You've all been one of those points at some point in different classes. Okay, I'm really sorry. I got like a cold going on, and I just am going a little crazy. All right, you guys still okay? So here, let's formalize some of this. Between these two main things here, this one, the one about beers, and the one about hours studied, which one has obviously a negative correlation? Which one would you say must be the negative correlation? The beers or the hours studied? The beers definitely have a negative correlation. It's a negative slope. So obviously this one has a positive correlation. So here, let's formalize some of this stuff up. There is a variable, there's something called R. It is the correlation coefficient, or the Pearson product. Pearson just happens to be the name of the stats teacher I took. No relation to the Pearson that made this. Stay with me, stay with me. R is sort of like, in a sense, it's like a two-dimensional standard deviation kind of thing. It measures how strong a relationship is. If it's perfectly positively correlated, what would that even mean? A perfect positive correlation would mean that you have points that perfectly grow. Oh my God, I can't do this. Just pretend like, oh, get out of there. That's absolutely disgusting. Go away. Just go away. All right. They all line up perfectly on a line. So let me try this again. I'm going to try it again. A perfect, you can do it. You can, why are you doing that? Oh man, I have no idea if this is annoying. It's annoying me. All right, all right, why are you doing that? Go away. Someday, holy crap, the whole thing just went freaky. Okay, I'm going to give up. I'm sorry. So a perfect positive correlation would be points that perfectly increase, that all lie on the line. That would be R equal to 1. So if R is 1, they line up perfectly in a positive slope. No points are off the line. They're all on the line. -1, they line up perfectly in a negative slope. So what happens if I start to pull those points apart? In fact, this is driving me a little crazy. Here we go. Let me turn off the geekiness that is happening behind me. Okay, I got to be able to do this. Comparatively, I can draw better up here. So, R equal to 1 would be points that line up perfectly like that, right? R equal to -1 would be points that line up perfectly on a negative sloped line. Cool? So then if I had something that was sort of like in the middle, if I had something that was like this, that would be maybe r equal to 0.9, maybe. Maybe this is r equal to 0.9, right? Is it perfectly 1? No, it's a little bit away from 1. So what do you think r equals 0 means? What would r equals 0 mean? If r equals 1 is perfect positive, r equals -1 is perfect negative. Yeah, good. They're all over the place. They're measles. So that would be something like, can you guys see that? Yeah. That would be something like, bah, 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 bah. There's just no relationship, right? They're just kind of scattered. I like it. But there's another option too. What about this? Does this line up perfectly in a line? Yes, they do. But this is no correlation. This is no correlation because this would be like you drink 1 beer, 2 beers, 3 beers, 4 beers, and you still have the same grade. So is there a relationship between the variables? No, one of them doesn't give a shit about the other one. Okay, I like it. I like it. So it's got to be some kind of a slope between the two because that would mean that maybe one of them makes the other one increase or the other way around. Okay, maybe. Okay.
What would R be in that point, in that case, or it would
0.
be 0? Okay.
Yep. There's no correlation. They don't affect each other. I like it. So either, how do you show that they don't affect each other? They're just randomly all over the damn place. Or it's like this or like that because the one variable doesn't give a shit about the other one, right? If it's straight across or straight up and down. It's like how high I can jump versus how tall the tree is out there. I'm going to jump really high. The tree is still the same height. Of course it is. One doesn't care about the other one, right? Okay, maybe. So, I don't know. If I was a student in this class right now watching this insane thing on Zoom, I would say to myself, what the shit are the problems going to look like? Dear God, I kind of get the idea, Jeff. What am I going to do to get this shit? So there's one last thing before we get there. Oh, look, somebody's got it printed out. Dude. Let me see. So 2 things about this. And it's kind of nifty. Let me see if I can get you guys to agree with me. Every time we got a new set of data, what were the 2 things we always had to figure out how to find? The mean and the mean and the okay. R is sort of like a standard deviation. It isn't really because it can go negative and all that kind of shit. Are you guys with me? But it's kind of like related to how spread out the data is from the line. The line is the graphical average. So it's kind of beautiful. I don't care what the data is. Every time I got a new set of data, I want to figure out what the average is, which means figuring out the equation of that line. And I want to figure out what the, you can do it, Jeff, standard deviation is, which in this case is the R. I like it. Okay, so.
Would standard deviation in like a 2-dimensional sense be more of like the slope or no?
No, they're related. They are related. But again, it's kind of like if I have a very small positive slope, R is 1 if they're all, and then if I have a really, really big positive slope, R is still 1 if they're all on the line. But R positive does mean a positive slope. R negative does mean a negative slope.
Okay.
I like it. And there actually is a mathematical relationship between the two. It's just a little bit gross. But R doesn't equal the slope. You got to be careful. Yeah. Any other questions at the moment? Okay, so this is going to be exciting. I got to figure out the best way to do this. This whole chapter basically is going to be on the calculator, right? Good Lord, I'm looking like really crazy today. Let me see if I can just go all in. So I'm going to try to show you. In fact, let me ask you this. I'm not sure how you guys are doing things in your calculator. Not everybody has a calculator. Has everybody discovered an app that mimics the calculator, or do you have a calculator, or are you just not doing the problems that require a calculator? I don't know. You're going to need something to be able to do this. I don't see anyone speaking up, so just let me know. Send me an email, something. I can try to help you figure out something. If you don't have a TI emulator app, or if you don't have an actual calculator. Okay, so let's do this. Gosh. On the other side of this sheet, so I just scroll down for you. I've made up some data. So can you, everybody right now, with whatever the hell you use, calculator, phone app, whatever, put the beers and the grades into L1 and L2. So let me get things started. So in L1, I'm going to put the beers 0.5, 0.7. This one right here, right? So we're going to put this into L1 and L2. Does anyone not know what I'm asking? Everybody know what they're doing? I don't see anybody saying anything. Can you share screen? Oh shit, I'm sorry. There, thank you. I forgot I wasn't sharing screen. Please tell me these things. I'm not doing that on purpose. I'm not like, let's see what they do, those crazy kids. All right. Can you guys see it now? Yeah, please speak up. I'm a human. I forget this shit. I forgot I wasn't sharing anymore. Now you can see it. Hey. So put the beers into list 1 and put the grades into list 2. Do you think you should sort these? Is that an answer to the question? Do you think you should sort these? No, you should never sort them, because they have to stay with each other. Like 0.5 goes with 98 and 0.7 goes with 68, right? So you don't want to sort each list, because then all of a sudden you've taken people and you've torn them apart. Oh, it's terrible. Don't do that to people. Oh my gosh. Oh, so couple things. One thing I do when I'm putting longer lists of data in is I'll stop somewhere, like right here, I'll stop, and I'll make sure that when I type 82, it actually goes with 2. Because what really sucks is to get to the end of a list and it doesn't match up with how long the first list is. Do you understand what I'm saying? That doesn't make any sense. All right, so it should, look like that in the calculator, right? All right, this is even more nerve-wracking than normal, trying to teach this technology stuff over Zoom. Oh, I'm gonna have to stop in a minute, RC. All right, guys. So, anybody not got all that data in yet? You guys are good? Okay, not seeing anybody saying anything. Let's go to the next step. Here's the exciting step. Now, I want to calculate a bunch of stuff related to the data I just put in. We know how to do that. We know where to go. We go to stat calc. That's where I go to calculate. Now, normally we do 1 var stats, and you might be tempted to do 2 var stats. In fact, let's do 2 var stats right now. Don't we have 2 variables? Yeah, we got beers and grades. Let's just do 2 var stats right now. We're actually not going to do it again. I just want to show you what it tells you. So if you select 2 var stats, right? Go to stat, go to calc, select 2 var stats, just to show you what it does. And I'm going to make sure that, for me, I'm going to make sure that it's L1 and L2, right? You guys see that? If you have an older calculator and it doesn't show you that, it just says 2 var stats, it'll default to list 1 and list 2. You can just hit enter. So when I do that, I get this. Do you see now with a newer calculator, I can see more on the screen. Do you see how I can see X bar and Y bar? And which makes sense because I've effectively got an XY table, don't I? X is beers, Y is grades. So I can see the average number of beers consumed was 2.3 and the average grade was an 84. I like it. And if you scroll down, you can see some more stuff about, let me see if I can do this. Scroll down, you can see more stuff about the grades. Blah, 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 blah. It gives you the 5-number summary for the grades. And if you scroll back up, well, shoot, I want to show you that. Get out of here. All right, anyway. So we're actually not going to use that. Because, just because. I'll show you here in a bit. Let me show you what we are going to use. So if you go to stat calc, which one of those looks like it's going to tell you the equation of a line? There's actually 2 of them up there, which is really silly to me. Which one will calculate the equation of a line? No, not number 9. Number 9, I don't know if not everybody knows this, but have you ever done logarithms? If you've done logarithms, number 9 is natural log regression. Well, what about number 4? Yeah. So 4 and 8, this is really, really, really dumb. 4 and 8 are the same thing. It just gives you, one says A is the slope and the other one says B is the slope. I don't know why they put both of those in there. I do not know. So let's just use 4. We're always going to use 4. The LinReg stands for linear regression. So if we do number 4, I get this, right? So I just want to make sure that my X and my Y are L1, L2. And then I'm going to go down to calculate. Now, if you don't get all that, you just have to hit enter. It defaults to list 1, list 2. Please let me know if you're lost. This is what I end up getting. Some of you guys will not get all of that. Do you get A and B at least? Everybody get the A and the B? I'll do it again if you need me to. So again, if you go to stat, get over here. Where are you at? There. Stat, calc. Oh, crappity do that. It's not you. Go down to LinReg, go down to number 4 to make a, I'm trying to figure out the line of best fit. So that's a good clue. Where's enter? There's enter, right? List 1, list 2, go down to calculate, and I get that. Does everybody get negative 2.535, blah, blah, blah for A, 89.83, blah, blah, blah for B? Exactly. Did anybody get the R's to show up?
First of all, I didn't get the R's.
Say again?
I didn't get the R's. I just
yeah, so didn't anybody. Did anybody get the R's? Too bad. You should have paid a little more for your no, I'm joking. We can actually turn it on. Okay, all right. Is
So
everybody
when I'm trying to do my line regression thing, how do you change the lists? Because I have list 2 and then list 2 again for my X and my white list.
Just don't forget your lists are above your 1, 2, right?
Oh, that's right.
Second one to make it to list 1.
Okay.
Good.
Thank you.
All right, so so everybody's able to have at least, so you guys look like this. Let me see. I think most of you guys look like this. Let me do this. Ha, 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 ha. No, Jeff, you hit the wrong. Give me a second. You could do it, Jeff. There it is, buddy. Good job. Good job. We could do this again. We could do it. All right. Most of you guys, it looks like that. Is that true? Right? Okay, I like it. So I made my R's go away so I can make them come back. And I'm going to help you make it come back. And actually, it's on this sheet too, right here. Oh, scheisse. This step right here, if R doesn't show up, we're going to do those things right now. If it's your own calculator you're using, you'll never have to do this again. It's kind of a holdover from when they wanted to try to save processing power. You could turn this off. Nowadays, it's dumb as shit because these things have crazy processing power. So you never have to go turn this off. Just leave it on. It doesn't matter. So do what that says. Hit second, and then hit 0. So it should come up with this. It's actually a catalog of everything the calculator can do. Calculator. You guys see that list on your calculators? Everybody with me? Please, dear God, let me know the minute you're not with me out there. Okay. Continuing on. So we see this. Do you see the button that's got a D above it? Do you see that right next to the matrix that says D? So above the x to the -1, just hit that button. And now you should be in the D section of the list. So that button right there, the one that has a D above it, for me it's in green. Some of you guys, it might be in yellow. I don't know. Do you guys see that? So somehow the calculator does a day of the week function. You could put in, I think, the year, the month and the year and the day, and then it tells you if it was a Tuesday or a Wednesday. Anyway, sorry. I don't care about that. Is anybody not here with me right now? Okay. So now you want to go down to where it says, scroll down, just hit the down arrow, down to where it says diagnostic on. And then hit enter. So it should look like that. How's my battery doing? Oh, I'm almost dead. All right. Gotta plug you in. Is anybody not with me? Okay. And now if you do it again, if you go stat, calc, number 4, now your R should show up. And you never have to turn that off. It doesn't do anything bad. It's just kind of dumb. It's just a legacy. It's left over. It's like an appendix, right? I wish they would remove it so it doesn't get all infected. All right. Infected calculator appendix. I don't know. Is that a good band name? No.
What's the difference between R squared and R?
You know what it is.
Oh, that's right. Yeah.
All right, so whatever R is, R squared is just that squared. The reason it gives me both. All right, so for right now, R squared doesn't mean shit to us. It's sort of like sigma squared is the variance. It just means I haven't square rooted yet, right? But there actually is a purpose for sigma squared. There is a meaning to it. It's the variance, but there's more than that. And there's actually a purpose to R squared also. I'm not going to describe it yet. So right now, all I want is R. Why does that make sense? So, all right, and watch. This data, I made it so that the graph looked like this. You guys, right here, it looked like this. If I graph it, it's going to look like this. Should that R be close to -1? I mean, it's obviously going to be negative, right? But should it be close to -1 or far away from -1? Are the data points really nice and tight to the line, or are they not tight to the line? They are not very tight to the line. I expect this R to be further away from -1, closer to 0. And sure enough, we got frickin' -0.339. I mean, that makes sense. It's closer to 0, but it's still negative. So that's what that number means. The closer that number is to 1 or -1, the tighter the points are to the line, the stronger the relationship between the two. The more I trust the line to make predictions. So this line, I would not trust it to make predictions. It's pretty damn weak, if good enough for anything. So, so we calculated both R, and what's the line of best fit? What's the slope of the line? What's the slope of the line of best fit? You can do it. What's the difference between the stats equation for a line and algebra equation for a line? There's just one letter difference. What letter is normally where A is in algebra? M, I love it, which people think it's comes from the French word for walk, marcher. I have no idea if that's true. Nobody knows if that's true. Whoever did know is dead. So my line of best fit, I'm going to put it into the chat so I can have it for later. My line of best fit is -2.535 x, stop going away, plus 89.83, gather, plus 89.831 roughly. I believe, yes. All right, please let me know if I have lost you somewhere. Have I lost anybody anywhere? Oh my goodness. Okay, all right, so let's put that in here. So what did we get for R? We got, holy macaroni, that is huge. What did we get? I forgot. -0.339. Is this a strong correlation? No, it's probably not even a correlation. I'll get into that later. What kind of correlation would it be? Negative, weak. Are you guys with me so far? I mean, this is basically what we said earlier. Oh, I can just put it right here, Jeff. So what is it? -2.535x plus 89.831. So, oh, I forgot the negative. Oh, I put an equal sign. That's always good, Jeff. So the slope is -2.535, and the y-intercept is 89.831. You never thought that would be useful, did you? You're like, what's this shit all about? Yeah, you do. Holy shit, algebra has a purpose. Oh, all right. So no. I'm not seeing anybody say that they're lost at the moment. So I'm going to go with that. Now, this calculator costs plenty of money. The dumb thing should be, and it's a graphing calculator, it should be able to graph these damn points for me, right? Do you see above y equals where it says stat plot? That sounds very encouraging. So if you hit second y equals, you come up with this. Yeah. All right. I'm going to assume everybody is with me. Can everybody hit 4, enter? So it looks like this. Just to make sure we've turned everything off to start with, so we only have one thing turned on. So plots off, done. So go to second y equals, hit number 4, enter. Okay, nobody is saying they're lost, so everybody is with me, is what I'm going to assume. As I sniffle, I'm sorry. This is a fantastic, I sound like our president. I got to tell you. Oh, sorry, I'll stop. China. All right. So now what I want to do is I want to turn that first plot on. I want this thing to plot these damn points. Can I explain what part again? So if I go, just the part about the stat plot. So if you hit second y equals, you get into stat plot. It'll look like that. Second, and then you hit y equals. You don't have to hit them at the same time. Second is like the shift key. Is that cool? Is everybody with me? Damara, is that all right? Did you get there? Damara, are you still there? What happened? Can't find y equals. Y equals is up here in this corner. So it's in the upper left-hand corner. So it's right there. Upper left-hand corner of the calculator. So you hit second y equals to get here. And then just real quick to hit 4, enter, just to make sure we all start with all the plots turned off, because there could be some weird shit in there. Now come back in, and let's all select number 1. Hit enter, and it looks like this. Notice something. Look at all those things you could make here. You can make histograms. You can make box plots. Oh, too bad. Too bad if you didn't read your manual on how to use this thing, but I'm not going to show you that shit. Ha! Sorry. All right, stop. So I want to turn this bad boy on. So I just hit enter. Where's enter? When I'm on top of the on button, I want to select that first one. See the type? I want it to be scatter plot. So I want it to be the points, the first type. Make sure your X and your Y are L1 and L2. Okay, how's everybody doing so far? Right, so you want it set up basically just like this. On the first type, so you make a bunch of points. L1 is the X list, L2 is the Y list. You can then choose what symbol you want to use for your data points. You want to put a square. Obviously, I pick a square. Are you positive? Are you a speck of dust in the universe? Are you an even smaller speck of dust in the universe? Totally your call, which symbol you want to use. And then for me, I can pick what color I want it to be. So what color do I want it to be? Let's see. Gray is awesome. What about magenta? Sure. All right. Woo! All right, let me stop for a minute. You got to let me know if you're still with me or not. Oh, yeah. Again, remember the TI calculator guide that's on the website that you could certainly download anytime you want to. All of these steps are on it. It's amazing. So if I hit graph right now, look how this is kind of dumb. Look at that shit. That's shitty. So many things wrong with that. I mean, what the hell? So what I always, in fact, for you guys, it's probably going to look way different. For some of you guys, it's going to look like this. Right? It's just nothing, right? You're like, okay, that's good job, Jeff. So whenever you put new data in, you want to hit, how did you get there? I just hit graph. I just hit the graph button. It's on the other side from y equals. And then I don't know what, it could look like almost anything based on how you've got it set up. But I can force the calculator to find the data. It costs enough money. If I hit right in the middle, see where it says zoom? So if I hit zoom, and then which option do I want? Well, I probably want the option that is the name of our class, number 9, zoom stat. If I hit zoom stat, it will zoom in to where my data is. Let me do all that again. In fact, let me do something real quick. I have something right now in y equals. I have stuff. I'm going to clear that out. Make my y equals clear. So if I hit, where was I? If I hit zoom, Jeff, zoom, and then number 9, zoom stat. It's number 9 for me. It might be different for some of you guys. It should end up looking like this, depending on what symbol you use. Okay. Everybody okay? Anybody not okay? What time is it? Oh boy. What year is it? All right. So the last thing I've got to do. So real quick, do you guys see how that does look like? Why am I making this such a small screen? That would be so much better, right? I'm sorry. Right? Please let me know when I do stuff like that. But just to show you this again, it should look, I try to make it look a lot like that first, this guy right here. Don't they look the same? So how do I get that line of best fit to show up? All I got to do, y equals, right? That's the line, y equals. So I hit the y equals button, y equals. And then I can put the equation in. Negative, negative 2.535 plus 89, oops, x. So you need your x in there. Hit the x button right there. There's your x button right there. Right there. X, 2.535x plus 89.831. I'm just putting that line of best fit equation in there into y equals. All right, how's everybody? I don't see anybody screaming, yelling, crying. Nobody. Hopefully everybody's okay. I'm gonna just keep going, right? So now if you hit graph, it's actually gonna put the line of best fit on there. Hey, look at that. Look at that. Look at that. You need to have a way to do this because on the final exam and on the next quiz about, the quiz for this, I'm going to need you to put this up to the screen and show it to me. I don't know what the hell I'm going to do. For the final exam, I'm going to do that because we're going to be Zooming the final exam anyway. On the quiz, I might make you copy it from your calculator onto the paper. I don't know. We'll see. Or maybe you can you could just take a picture of it. Duh. You can just take a picture of it and shoot it to me. Yay. All right, so I'm not seeing any questions. So I want you guys to do this. I want you guys to do this data for grades. Do all this data here. Put those in the L1 and L2 and do everything we just get. Oh, hit graph. What do you mean to hit? So if you got the line in there, if you got the line into y equals, just hit the graph key. There it is, the graph key. And then it should look like that. Okay. I am going to blow my nose because it's driving me crazy. Okay. Please let me know if you have issues. Oh, the R stands for the what's called either the correlation coefficient or the Pearson product or whatever. It's just the measurement of how strong the relationship is. So 0 means no linear correlation, 1 means perfect positive, -1 means perfect negative. So it's a measure of strength of correlation, how tight the points are to the line. Okay. The closer R is to 1, the stronger positive it is. The closer R is to -1, the stronger the negative relationship. No, it can't pass 1. And I'll show you the equation for it, just so you can see what I'm not making you do. There is an equation for R, and it's a beautiful, oh my God. You know, me saying that is really, you know, like, holy shit, it must be really gross. It is really beautiful. Who's doing that? There you go. You can't draw on it no more. Try to draw on it again. Little red line person who drew that red line. Try to do it again. Can't do it. Hopefully. I don't know. Hopefully I just turned that off. I don't want people drawing who knows what up there. This is the exciting part of statistics. Data entry. It's so remarkably amazing. Like totally. All right, cool. Bow, 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 bow. Bow, 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 bow. Oh, crap. Let's see. Where are you again? Mm, 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 mm. Mm, 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 mm. There you are. Let's see. Has everybody got all the data? Do you still need that? The data? Has everybody got the data? Data. I'm going to assume that's a yes. Where would you be? 12.3. How do I move this stupid thing? You people. Yeah. Let me see. There we go. Can you guys all see the book? Is that a yes for right now? I wish they had timestamps on these chat things. All right, I'm going to assume you can. So here it is. Look at this. Oh, it's such a beautiful thing. I don't know how to draw on this now, but there's the formula for R if I wanted to make you do it by hand. Just take that in. It's glorious. I want you to, we're never going to use that formula, by the way. Don't freak out, okay? But notice that the bottoms relate to the standard deviations. Stop it. All right. I don't want to do it. The bottom relates to the standard deviation of X and the standard deviation of Y. It kind of, and the top actually relates to the standard deviation of XY. So it kind of makes sense that R would have standard deviations of the two variables in it because it's supposed to represent general standard deviation of the data points. And if you didn't understand anything I just said, it's fine. It's kind of a nifty idea. It leads to a really, really, really crazy ass formula. So let me catch up to you guys. Are you guys, can you now see the data again? Anybody? I'm still not really used to how the share screen thing works. Yes, okay, good. So I'm getting this. I'm getting this here. Did I do it right? I think I double checked my data. Anybody else get that same stuff? Yes? This is what I got. Is this a stronger relationship than the one we just did a minute ago? Hell yeah, I mean, look at that R, that's close to 1, right? So basically the further from 0 it is, the closer to 1 or -1 it is, the stronger the relationship is. And in fact, right now, if I hit graph right now, it's gonna look like, it's not gonna be shit. I see 1 data point, right? So I wanna do a couple things. I wanna go to Y equals and clear that out, clear it out. And I want to go to zoom 9. Anytime I put new data in, I got to do zoom 9, and then it will find the data for me. Okay. So coming back. So now I can write down my R. It's 0.738. We're basically done, everybody. Just, I know it's time to go. 738. Is this a strong relationship? Yeah, sort of. It's medium. Decently strong. Positive, right? Positive, oisitive? Sure, man. Positivities? Positive. All right. The equation of the line of best fit is 0.657. Oh, shit, Jeff. 657x plus 70.967. All right. So if I put that in, into y equals 0.657x plus 70.967, right? If I put that in, don't forget the x, and then I hit graph. Look at that, that's beautiful. That's so beautiful. Now you can see where the R is decently strong. It's you know, it's not very strong because it's 0.73. I mean, it's not that close to 1, but it's much closer to 1 than 0 for damn sure. Wow. So that was a lot. So what I'm gonna post a worksheet that we're gonna look at Wednesday. I'm going to put that up on Canvas. You're going to want to take a look at it. Even if you don't, we're going to do it on Wednesday, but maybe just take a look at it. Yeah, and then of course Wednesday we got the quiz. We're obviously going to do more examples of this stuff on Wednesday. Okay. Anybody have any questions? It's pretty much past time to stop. Yeah, dude. Remember the hypothesis test last week, the quiz was just on means, and I told you we would have a percentage one this week. So this Wednesday, it's the hypothesis tests for percentages. It's that quiz. So hopefully if you didn't do all that great on this quiz, you can firm that shit up so you're ready for this next quiz. Some of you guys were using the p-hat stuff on this last quiz. It wasn't even one of the formulas I gave you. So that's definitely not what that, none of it was percentages. It was all means. This next one is going to be percentages, and I'm going to have type 1 and type 2 error questions on this next one. And then next week is going to be the correlation quiz. Oh shit.
Professor,
Yes.
are you gonna set up for corrections for like quiz number 6 and 7?
Oh yeah.
If we
So
have to?
something I realized, I'm glad you're bringing that up.
Uh-huh.
I did the separate corrections place, but then people are turning them in without the original,
Oh.
which really sucks because then I got to go back to the thing and find you and get your original and then put that up on the screen and then go back to the corrections and blah, blah, blah. So I thought maybe if I just let you turn corrections in, you know, you can resubmit the assignment as the corrections, and then I got it all right there. Does that make sense? No? Shit.
I turned mine in with like the quiz first, I think, or corrections first, but I turned it in all together. Does that also work? Or
Where'd you, I'm sorry, which quiz?
for like number 4 and 5, and you graded them and everything too.
Yeah, but
and
you
like,
put them in the corrections, right?
okay, yeah.
So like quiz 6 and 7, turn
Mhm.
the corrections in the same place you turned in quiz 6 and 7.
So resubmit it?
Yes.
Okay. Got
It's
it.
fine because I can see the dates for each one. So it's not gonna, it's gonna say late, but you're gonna be like, I don't care. That way it's just easier to grade because then I have the original and the corrections all in one place. Okay, all right. Any other questions, guys? Everybody else all right? Okay. All right, guys, keep on staying strong. I will see you Wednesday. And as always, if anybody I've had a couple of Zoom meetings with people individually. So if you need like extra time at some point, just email me or something. We can set something up. Okay. All right, guys. See you.